Hello and welcome to the second half of the JavaScript lecture. We're going to talk about functions and objects and arrays and control structures, more of the advanced stuff. Now, in general, object-oriented programming is an abstract concept in that across many languages it functions pretty much the same. We have this notion of a class, which is a template, which says these are the kind of variables and methods, and then we have instances where we make many of these things. And so these are the definitions from the previous lecture where I talked about PHP classes. So again, it has attributes, fields, properties, and then methods. Sometimes some OO patterns would call methods messages. And then it's a template, just like a cookie cutter. And instance is when we take that template, say I'd like to make one of these things, so it makes one. And if we're going to make bunches of them, we would make many different instances. And we use the word object and instance often very interchangeably. Method is code, and then there's data as well as code. And so the concepts, we use the word class and things like that, are very similar, but there is some differences in JavaScript object-oriented approaches. Function itself is in effect an executable statement. It itself is a function, and it creates the function, but it also returns a value. Okay, hard to explain this. When you have function, it makes the function and then returns it. You can either name it or have what's called anonymous functions. And so this concept is called first-class functions. And it really, there's lots of aspects to it, but if you can basically take a function and stick it in a variable, then you have first-class functions, okay? And there's some more subtle details to that. So it's probably just as easy to just show you how this works. So here is a very simple class. So we don't use the word class. We have this function, and it'll be called party animal. It currently takes no parameters, and it has a beginning and an end, and it executes. So unlike the PHP that we saw, which has an explicit constructor, this turns out to be the constructor itself. This code here is the constructor itself. So when we say, I would like a new party animal, it actually runs this code, all of it, all the way down, and then the function that comes back is returned and put in the variable an. Okay? So function makes a new function, basically. It, in effect, clones the code. And it runs this. Now, all functions need a way, all object-oriented classes and objects need a way to reference themselves. And the this in JavaScript is the way we do that. So this means this instance, the instance that we're dealing with. And we make a member variable just by saying this.x equals 0. That is, create a variable called x and set it to 0 in the current object that we're creating. And this next bit is the tricky part and the cool part, both tricky and cool. We're going to say this.party, which is a member variable, is an anonymous function. So you see this function, but with no name, that's an anonymous function. Currently takes no parameters. And then this is the code. We can look at this.x equals this.x plus 1. That's this same variable. And put out a console log message. And so when it's all said and done, this ends up with a method named party and a member variable named x. Okay? And so we run through this code which creates everything. It's kind of the constructor code of constructing and setting the variable to 0 and then creating the method. Okay? And then we get the object back, the instance back, called an. And we can say an.party, which runs this code once, over and over and over again. Okay? Oops, let me clear some of this. So it runs the code, and it runs that over and over again, and so that member variable gets incremented. And so the output of this will be so far 1, so far 2, so far 3. And that's because this x variable is getting incremented as the code is running. Okay? So that's the key, right? This AN variable has a x bit of data in it and a method named party. And we define it in the constructor, basically. Both those things are defined in the constructor. Okay? So the constructor is a little bit different, right? In an object lifecycle, we make objects, we destroy them, we run the constructor code when we start it. JavaScript doesn't have the concept of destructors, but if we go back to the PHP object-oriented, destructors in most object-oriented environments are seldom used. Okay, so we can think of this bit of code is in the constructor, and so at the moment we're running the new, it actually is running the constructor code, and so out comes that log message. Now, again, part of the whole idea is to create the class, which in this case is a sort of function with a special capability, and then we're going to make many instances. So here we have a couple of examples where we are going to pass in a parameter to this function, which is going to come from the constructor. So we're saying make a new party animal, and then this Sally is passed in to be nam. And so we then end up with, this.x equals 0, just like before. This.name, a member variable name, set to be whatever that is. In this case, it'll be Sally. And then console log, we've built the Sally object. And then we're going to create a member function, a method. This.party is a function that adds 1 to the x member variable and then prints it out. So we create s, the variable s, creates a new party animal with the parameter Sally. So it runs through this, builds the object, and then effectively, implicitly returns the object, and that gets stuck into S. And then we call the party method within that, and that says both what the name of this function is and what the current value for this is. Then what we do is we run down to here, we call it again with Jim this time, sets all this stuff up, sets the X member variable, name member variable, console logs Jim, creates the party method, and then returns, and it ends up in the variable J. And then we call J.party, and that comes through, and it's going to say Jim, and then Jim's X value is 1, because we started at 0, added 1 to it. And now we have this other member variable, other instance, still in S. We can call that, and that still holds inside of S the name of Sally, and we add 1 to X, and so it is now 2. Okay, so this is 2 instances of the same class. So this is the template. These are the instances of the class. So if you run through this, right, and the code basically comes through here. It just sort of defines the class at this point. As JavaScript's interpreting through here, it's defined the class as to what's going to happen. Now the code doesn't actually execute, it's just remembered at this point. And now when we're going to make a new party animal, it passes the Sally in, right? And then it starts running this code. And it creates basically an instance. This.x is 0. This.nam equals Sally. This.name equals Sally. And then we're going to have, there's a party method as well. And so that's all running. And then it returns and puts that into S. And so now we have this variable S that has 0 and Sally. And then we call S_party. Right? So we finish this. X is 0, Sally. And then we call S_party. Well, it goes and looks at this, which is currently S, right? Because we're going S.party. This is this.x equals this.x plus 1, so this becomes 1. Then it runs through, console log out Sally 1, because this is now 1. Then we come down to here, and we make another one. And we make another one, and it comes in this time, and its x is set to 0, and the name is set to Jim. And then it comes through, and it comes back, and it has a party method, and then that stores in the variable J. So here's J. Then we call J.party, and that goes and runs this code except with this instance. So this particular one is now incremented to 1, and then it prints out Jim equals 1. Then we go back to s.party. Well, that means that this is s, and it runs this code, and it adds 1 again, so that becomes 2. And then it prints out Sally 2, and then we're done. Okay? So this is 2 instances. Instance, instance. Okay? So again, the constructor in JavaScript is effectively the function itself. It's sort of implicit in the class. It's a little different. Now, let's talk a little bit about arrays. JavaScript supports both linear arrays and key value associative arrays, but they're kind of actually a little different than associative arrays in PHP. So linear arrays are really simple. You can effectively append into them, and then you have a linear array. You can create an array, looks a lot like PHP there, and then you can set the 0 item and the 1 item. That works as well, and then you just print them out, and you've got an array that's just got 2 items in it, and away you go, and use the index operator as you might expect. You can also use the array constructor, where you say array, and then you have a thingy, and you got a 2-item list, or you can use the constant syntax, which is square brackets, and you get the same kind of a thing. So those are linear arrays. Now, JavaScript also handles associative arrays, but really, they're not really associative arrays. They are objects. And so when you start doing key value pairs, associative arrays, they're really objects. And this can be kind of confusing. And you can either use the associative array syntax or the object syntax. And this got me in a lot of trouble when I first started doing JavaScript, because it's like, what's going on here? Is this an array or is it an object? And it really helped to understand that under the covers, it's really an object. So here's the constant format for effectively an object, right? So here's an object. It's got curly braces. So golf maps to golf balls, tennis maps to tennis balls, ping maps to ping pong balls. These, in effect, are member variables. That's the best way to think about them. And so balls.soccer, well, this is going to put a new one in, soccer balls. And then balls sub lacrosse, so this is the associative array syntax, and this is the very objecty syntax, then lacrosse balls. If you then print these things out, soccer and lacrosse look kind of the same. That's because they are the same. That's the key. These two syntaxes are equivalent. It's best to think of it as this one here. This is the syntax that's real, and this happens to be a convenient equivalent. Okay, so I think of these as objects with member variables named golf, tennis, ping, soccer, and lacrosse. But you can have member variables as strings, right? So that's why I like to think about this as member variables, as compared to in PHP we think of associative arrays as key value pairs, as well as in Python. And so here's the interesting thing now. If we did, here's our 3 member variables, golf, tennis, and ping, and they store golf balls, tennis balls, and ping pong balls. And I say balls.soccer equals soccer balls, so that's adding yet another one with a member variable soccer. But check this out. This is a first-class function, a perfect example of a first-class function. Balls.kick. Kick is a member variable. Function, this is an anonymous function. No name. No name. And we'll just have something, right? Console.log boom. And so this function right here is a first-class function. So it itself is returning a value, which is effectively the function code. And so if we dump that, we see that the member variable golf is a string, the member variable ping is a string, soccer is a string, tennis is a string, and kick is a member variable, but it's a function. So we have put a function in a member variable. And if you look back at that class definition, well, let's go back and look at that class definition. I should pull it up here. That is exactly what's going on right here. This function is the code for the function. And I'm making a member variable called party, which is a function. That's the notion of first-class functions, that you can just assign it to a variable. You can take code and assign it to variables. And when you think about it, first time you think about it, you're like, oh, that's like super crazy, right? But it's not, okay? So let's talk a little bit about control structures for JavaScript. They're very much like most of them. If statements work like you would expect. While loops work like you'd expect. Counted for loops work like you'd expect. And loops break and continue work like you'd expect, because it's all very C influenced. So here is the definite loop for, the in, right? And so if we have in this case, this is an object with 3 member variables, for ball and balls, that's going to sort of iterate. Ball is now going to iterate through these 3 things. And if we print out golf, which is a string, and then we look up balls sub ball, so that is a string, balls sub golf, balls sub tennis, so it prints these guys out, right? So that's an in. It uses the in keyword, similar to Python. Oops. Okay. Now, what if in this bit of code, I not only have 3 member variables that are strings, I also stick .kick in, and I make it be a function. So we have golf, tennis, and ping, and kick. And then I write for ball and balls. It's going to go through all of the member variables, kick, ping, tennis, and golf. Not necessarily in that order. So then I print out balls sub ball, right? So ball is going to be golf, tennis, ping, kick. And then I print out this thing. And so golf gives me golf balls, tennis gives me tennis balls, ping gives me ping pong balls, and kick gives me the source code to the function. Kick is a member variable. Its value is a function. Freaky but powerful. Freaky but powerful. So we can do things like we can check the type of things, we can call these functions, we can check to see if the type of this is a string. Remember, type of is a operator that checks the type of this, and this returns a string. In this case, if it's not a string, I can skip around, so I can print out only the strings. So that's another thing that we can do. And so that's a quick overview of object-oriented programming in JavaScript. It has all the same basic concepts of object-oriented programming in other languages, but the power of the first-class functions makes it really, really interesting. And once you get used to it, you'll realize that it's a really pretty and elegant and powerful pattern. See you in the next lecture.